We're going to cover sections 14 and 15. We are going to be looking at area, perimeter, and we will be looking at scientific. Those are the three main things for today. So, to begin with, when we find the perimeter of a figure, what we do is we add all of the sides. So whatever figure that you may have, for example, I'm going to give you a problem to find the perimeter of a rectangle. So to start off with, you would draw a rectangle. With a rectangle, you know opposite sides are equal length. If I tell you that the length is 15 and a half, and I tell you that the width is 11 and 75. Now, I wrote it in two different ways. One is a fraction, the other is a decimal. It does not matter which you choose. And in this case, if you're going to use your calculator, you can leave them as being separate. Personally, I like to do all of mine as a decimal. So my half would be a 0.5, and then I'm going to relabel the width. So to find the perimeter, I'm going to have 11 hundredths, 5 tenths, other 15 and 5 tenths. So we're going to key this in. Oh, wait a minute. Let's try that one more time. And I'm having a little bit of a lag here. So be careful if that's happening with you. Okay, and that gives me 54 and a half. So that would give me 54 and a half. And if my units are feet, with perimeter, it's still going to be feet. Now, when we do the perimeter of a circle, we have a special term to use. And that term that we use is the circumference. The circumference of a circle is one of two ways, either pi times diameter, or we can say 2 times pi times radius. Remember, we have a circle. The distance from side to side would be the diameter. And if you are given just from the center to the outer edge, that would be your radius. So they may give you one or the other. So for this particular problem, what I'm going to do is I'm going to ask you how much fencing is required to enclose a circular garden whose radius is 20 meters. So we're being told that the radius is 20 meters. We want an exact answer. And when we ask for the exact answer, that would be in terms of pi. And then we want an approximate answer. And with the approximate answer, use 3.14, okay? So since we're using the radius, our exact is going to be 2 times pi times the radius of 20. So 2 times 20 is going to give us 40, and then the pi symbol, okay? Now, when we do the approximate, we know that we have 40. So 40, in place of the pi, we're going to multiply by 3.14. So we're going to take our 40 times our approximation of 3.14, and we get 125 and 6 tenths. We are using meters, so our unit for circumference is just like a perimeter. It's still just going to be meters. When we are looking at area, If you will go to page 2-84, you're going to see a list of formulas. So depending on which particular shape you were given, you have your formulas all listed here. Now, granted, when you take a test, you will not be given the formulas. You will need to know those. We have already been working with these formulas from DMA10, and you will continue to see these formulas throughout the rest of your DMA modules. Let's start and let's do a problem where we're being asked to find the area of a triangle. So we want to do the area of a triangle with a base of 2.8 inches and a height of 3¼ inches. And they ask us to draw a picture, write the equation, and solve. So when we draw our triangle, it doesn't specify whether it's a right triangle, an acute, obtuse, which type of triangle. I'm just going to draw a basic triangle here. My base is 2⅞, so that's 2.8 for the base. When it mentions the height makes where you have your 90-degree angle. So what's in red is a height. The height is 3. And personally, I write this as a decimal. And to write it as a decimal is a 0.25. 1 divided by 4 is 25 hundredths. So that's how I'm going to write it in our problem. Our formula for area, when you first look at the formula, they write it as 1/2 times base times height. And you may write it that way, and that is fine. For me personally, I know that 1 times b and h is still going to be base times height. I personally like to do base times height and then take that answer and divide by 2. You may do it either way, both are acceptable. So I'm going to have here 2.8, 3 25 hundredths. That answer is going to be divided by 2. So 2.8 and 3 25 hundredths. What I'm going to do is get my solution, and then I'm going to take this and divide by 2. That'll give me 4 55 hundredths. Now, since we're referencing inches, when we have area, you're multiplying inch times inch, so that's going to give you inches squared. One of the problems that most students find most troublesome is this particular problem. It's on page 2-88, and this is question number 7. Carly wants to install a 3-yard walk around a circular swimming pool. The diameter of the pool is 15 yards. In order to buy the concrete, she needs to know the area of the walk. What is the area of the walk? Use 3.14 for pi and round the area to the nearest tenth. Be sure to draw a picture. So what I'm going to do is I'm going to draw, this is going to be my pool. And then around the pool, she wants to have a walkway around the pool. Okay. Now what we were told is that the diameter of the circular swimming pool is 15 yards. So the diameter is the distance side to side. The diameter is 15. When we're calculating the area's pi times radius squared. Now already I see they gave me that the diameter is 15. In order to get the radius, we're going to take a diameter of 15 and we're going to divide it in half. When we take the 15 and divide that in half, we get a radius of 7 5/10. So it was important that I calculate what the radius is, and this radius here is for the pool, okay? The other information they gave us is that the walkway around the pool is 3 yards. So that means if this other circle around it represents how far out it goes, the concrete's going to be poured from the pool to that edge. So that means here is a distance of 3, and here is also a distance of 3. So if I want to get the total diameter of the walkway and the pool, I'm going to take 3 plus 15 plus 3. Okay? So 15 and 6 is going to give us 21. That would be the diameter. I'm going to need the radius. So to find the radius, I'm going to take the 21 and divide that in half. And that's going to give me 10 5/10. Okay? So we already have some preliminary work that we're going to have to do. What we are looking at, what they want to know is the area of the walkway. So what we need to do is find the total area, which means everything. And then we're going to subtract the area of. That will leave us with the area of. Does that make sense? We're going to calculate the area of absolutely everything, everything that's inside that outer circle. We're then going to subtract and cut out, it's kind of like a donut. We're going to cut out the pool, like the donut hole. We subtract the pool's area, and then that leaves us with just the area of the walkway around. So that's pretty easy. Okay, so let's do the area of everything. That's going to be pi times 10.5 squared. And for pi, we're going to use 3.14 times 10 5/10. Whoop, 10 5/10 squared. Make sure it's squared. That will give us 346, and 185 thousandths. And let me make note here, pi, we're going to use 3. Okay. That answer we're going to subtract from this area. This area is going to be pi times 7.5 squared. So pi times 7.5 squared. The pool is 176 and 625 thousandths. And from this, we're going to now do our subtraction. So 346 and 185 thousandths minus 176 and 625 thousandths leaves us with 169 and 56 hundredths. 169 and 56 hundredths. Now, in the instructions, it asks us to round the area to the nearest tenth. So it specifically says to the tenths place. So the 5 is in the tenths place. The digit to the right is a 6. That is going to make the 5 round up to a 6. And for this problem, we are dealing with yards, and our units for area is always going to be square yards. This is the most complicated of the ones that you have for the workbook and online. Unfortunately, they don't give you one like this on the test. They just give you one applying the basics of the area. The last section that we have is scientific notation. Scientific notation is a way to write values that could either be less than 1 or they could be larger. They could be very large numbers. It's a way for us to write really huge numbers and write it in a more condensed format. When we do scientific notation, our first number that we're going to use is going to be between 1 and 9. So in other words, it could be 1 point, 2 point, 3 point, 4 point. This number here is going to be greater or equal. And it could also, that number is going to be less than or equal to 10. It won't be, less than 10. It's never going to be 10. It could be 9.99999. It's going to be, in other words, single digit. We're then going to write a multiplication and then 10. Now, if the exponent is positive, you move your decimal to the right. If your exponent is negative, you move your decimal to the left. So let me give you an example here. If I were to give you, let's say, 5,420,000. If I want to write this number in scientific notation, I look at my first few digits. I have a 5, a 4, and a 2. To make this read as a whole number that's single digit, I would place my decimal here between the 5 and the 4. Then it's going to be times 10, and what is my exponent? Right now, the decimal technically is on the far right side. So it would actually move 1, 2, 3, 4, 5, 6 places to the right. So my exponent would be the 6 because between the 5 and the 4, I count the number of places that it would move in that direction. If I have this value, I first start by taking my digits, the 1, the 2, and the 8, and to make that a digit, I would put a decimal between the 1 and the 2. 8 times 10 to a power. So if I placed my decimal here and went to its original location, I would move it 1, 2, 3, 4, 5 places to the left. So that would be a 10 to the negative 5. You will take problems and you will go from one direction to the other. Let's do another. Let's say I give you 1 and 25 hundredths times 10 to the negative 3. So if I'm going to write this down, I would start by writing my digits 1, 2, and 5. Initially, the decimal is here between the 1 and the 2. The negative 3 means I'm going to move left 1, 2, 3 places. When you move left, the decimal has to remain in front. This number does not mean how many zeros you necessarily add because that 1 counted as one of those 3 places. I'm only going to add 2 zeros. If I give you 8 hundredths times 10 to the 8th. Since it's positive, I know I'm going to move my decimal to the right. I would write down my digits, but it doesn't mean write 8 zeros. It means if I start here, I move my decimal right 1, 2, 3, 5, 6, 7, 8 places. So it would go to the end. In this case, I'm filling in the inside of the weight. I would actually add 6 zeros because of the 8 places, the 7 and the 9 took 2 of those spaces. Okay, let's do 2 more. And on these, I'm going to give you the decimal and we're going to put it back in standard notation. Okay, so let's say I give you, if I give us this value, first I would write down my digits, and I would put the decimal point between the 2 nines. Then it's going to be times 10 to a power. So if I were to place my decimal between these, to get to that location, I would have to go left 1, 2, 3 places to the left. So my exponent here is going to end up being a -3. If I were to have the decimal would go between the 2 to make it single digit. And then I'm going to count how many places I would move my decimal. The understood decimal is on the far end. So I would move it 1, 2, 3, 4, 5, 8. So that would give me a +5 for my exponent. And ladies and gentlemen, that is all that we have for our scientific notation.